Before I end this discussion on regular expressions, I want to swing back to the first two I showed you at the start of this section. I'll walk through both of these with you now. I had promised you'd understand these, or a lot of the parts, by the end of this section. Hopefully, you're starting to recognise some of these meta-character combinations. Getting back to the code, I'm going to start with a new class, calling it Review, and I'll put it in the dev.lpa package. I'll first create a text block with a US phone number on each line, but in various formats. Any one of these could be a valid format for a 10-digit US phone number. I'll create a pattern with the regular expression shown on the slide. I'll call this phone pattern and assign that the result of the compile method with the text string from the slide. This pattern starts with 2 backslashes before an opening parentheses. Hopefully you'll remember parentheses are used in regular expressions as a meta character, identifying groups in most cases. But in this case I want a literal opening parentheses because I want to match a parentheses character in my string, so I need to escape it this way. Next I'm using a character class that defines a range, in this case the digits 0 through 9, because I only want numbers. The 3 in curly braces is a quantifier that says I want 3 digits here after the opening parentheses. This is followed by a closing parentheses, and again I need to escape it for it to be used literally. I've included a space character after that, which is a literal space, so it won't include all white space. In other words, it won't match on a tab, for instance. I again have a character class in square brackets for the full range of digits, and that also has a quantifier, meaning this has to be exactly 3 digits here. This is followed by a dash, which doesn't need to be escaped in Java, and then again digits, but ending in 4 digits this time. Now that I have my regular expression, I want to check my string for all matches. I'll set up a matcher variable, phoneMatcher, getting an instance from phonePattern's matcher method, passing that my phonelist text block. I'll use the results method, printing the value of each match results group method. If I use the group method without an index, this will print the entire matching subsequence. Let's run this now to see what we get. Only the phone numbers that match this expression will get printed, and here there's only one, the first entry. This regular expression is pretty restrictive, and maybe that's a good thing, depending on the use case. But I want to make this more flexible. First, let's make the first opening parentheses optional. Remember that the quantifier asterisk will match on 0 or more characters, so I can include an asterisk after the opening parentheses. I will do the same thing after the closing parentheses. This will make the parentheses around the first 3 digits optional. If I run this, I now get 2 phone numbers that match this one expression. In this expression, the way it's written now, a space is always required after the first 3 numbers, but I'm going to change that. I'll create a character class that will consist of the closing parentheses and a space, but instead of a space character, I'll use the character class for any white space. First, I'll delete everything after the first numbered quantifier, up to and including the space character. I will define my own character class, and that starts with an opening square bracket. I'll include the closing parentheses first, and because it's in square brackets, I don't have to escape it. Next, I'll have 2 backslashes and an S, which is the character class that matches any white space, and then a closing square bracket. I'll add the asterisk quantifier. This character class with an asterisk quantifier will match either a closing parentheses or a space 0 or many times. Now let's see what we get when I run this. I've picked up another phone number, the second one, that doesn't have a space after the closing parentheses. I can actually remove one of the backslashes before the S in that character class. This compiles okay, but notice IntelliJ is giving me a warning. Use of \S in the middle of line is discouraged, so I'll undo that. Let's keep going. I'll include a dash in that last character class I created so that a dash could alternately follow the first 3 numbers. I'll copy that character class and its following asterisk and paste it where I have the dash in the expression. In this case, I want to remove the closing parentheses because it's unlikely a user would include one there. Running this code has now matched all the phone numbers I had listed. You can see this is a much more flexible regular expression. It could allow users some flexibility when entering a number in a user interface or matching different phone number formats in a file, for example. There are different ways to specify a number, and I'll show you 2 ways to do this next. I'll replace that second range that's in square brackets with just \\d. I don't need square brackets if I'm only using one of these special meta characters. For that last range of digits, I'll do something similar and replace it with \p, and then I'll select digit from the list that IntelliJ displays. Running this code now, I get the same results as before, confirming that these replacements are good alternatives to the 0 to 9 range in square brackets. Let me encourage you though, not to use 3 different expressions for digits as I did here in a single expression. Try to be consistent, at least in the same regular expression. This slide shows some common ranges and some alternatives that mean the same or similar things. I already showed you that the 0 through 9 range can be replaced with either a \d or the \p, and digit spelled out in curly braces. The range with lowercase letters a to z can be substituted with \p and lower spelled in curly braces. If you need to support Unicode characters, you can use the java.lang.character classes. So for lowercase, you can see this has Java lowercase in curly braces after the \p. There are similar predefined classes for uppercase letters, and there is a combined class for US ASCII alphabetical letters. Words are described by letters, digits, and the underscore as shown by the range. Whitespace, as defined by \s, will match a literal space, a tab, a new line, and carriage returns, etc. Again, the Java whitespace will match more Unicode characters. Okay, so now let's look at the more complicated regular expression that matches on HTML tags. I'll again set up a text block, which I'll call HTML snippets, representing different HTML tags and some different ways you can format them. I'll start with H1, making the tag uppercase. Next is H2, lowercase h. I'll have a simple P or paragraph tag. Again, a paragraph tag, but I'll include the style attribute. H3 is another header tag, level 3. In this case, I'll have an attribute, ID equals third. Here I'm using the XHTML way of declaring a break tag. Finally, a simple paragraph again. I'll set up my pattern using the regular expression from the slide. Okay, so let's take this regular expression apart. This expression starts with a left angle bracket. An angle bracket is a meta character when used if you're naming a group, but the regular expression processor is smart enough to check context, so I don't have to escape it here. This means this regular expression will start matching when it finds the opening angle bracket of a tag. Next, there's a group defined which is automatically indexed as group 1. Remember, group 0 is the entire matching subsequence. In this case, there's \w+ in the parentheses. The \w meta character means it's a word character, so it's an alphabetical US ASCII character in either lower or uppercase, an underscore or any digit. It's followed by the plus quantifier, which means it will match at least one word character, but could match more. This is being grouped because I want to pull out just the tag type, so H1 or P, or BR for example. After this, I have a character class in brackets that starts with a caret. A caret in square brackets means to ignore the characters that follow, so in this case, a closing angle bracket will stop the matching. This is followed by an asterisk, so any character that's not a closing angle bracket is going to match. This is followed by the closing angle bracket for the tag. This code will match tags that have no body, as well as tags that have attributes. Another group follows. This group's purpose is to capture the text that's contained between the opening and closing HTML tags. You might expect this to be .* in parentheses, but there are some characters that we don't want to match on, so I'll again use a custom character class with a caret, so that any character that follows the caret will end the matching for this subsequence. These characters are new lines or carriage returns, the opening and closing angle brackets, and the \ character. Line breaks or carriage returns are called vertical white space and can be matched using \\v. After this, I have the opening angle bracket, the /, and the closing angle bracket. This just means the code will match any character that's not one of these, and because I'm using the asterisk quantifier, this can be empty. The final group is really only a group because I want to use a quantifier for the entire set. Here I have the opening angle bracket and a /. This is how most HTML tags end, and then they're followed by the tag label P or H1 or whatever. I'm using a back reference to the first group. This means the ending label needs to match the opening label. I'm also using a quantifier on this last group, meaning this could be omitted, as it will be in one of my examples, that uses the XHTML formatted BR tag that includes a / before the closing bracket. There are simpler regular expressions for HTML tags depending on what you want to do, but this one should match all my samples. Getting back to the code, let's test this expression out. I'll create a new matcher and just call it M. I'll use the HTML pattern.matcher, passing it my HTML snippets. I'm going to use the results method again, because I find it the simplest way to do this. I'll print group 0, which is the match to the full regular expression. I'll print group 1, which is the tag type. I'll print group 2, which is the text between the opening and closing tags. Let's review the output we get from running this. All of my tags match, which is good. In the first case, the H is uppercase, but I still matched because I use //W, which matches on any characters A to Z, regardless of the case. Notice in the case where there were attributes, for example the style attribute on the one paragraph tag and the ID on H3, these tags still matched this regular expression. The XHTML version of the break tag, BR, also was matched, so that's good. I can replace the //W+ with the character class that it represents. You can see this is the letters lowercase letter a through Z, capital letter A through Z in uppercase, and underscore or digits 0 to 9. This is the underlying meaning of the /W. Running this code gives me the same results. Let's change the ending tag of the H1 to be lowercase and see what happens. If I run this code now, what I want you to notice is the full tag is missing the closing tag. The back reference I'm using is causing the match to look for a capital H1. There is a way to specify certain look-ahead behaviour for a group, and I'll add this here. At the beginning of the group, I'll add $I, and I'll include that in another set of parentheses. Notice that this is not an additional group. This says ignore case for the group. Let's confirm it works. I now see the ending H1 tag in the output. I can do something similar by setting flags when I compile the pattern. I'll undo that last change, then add a comma after the regular expression and include a new line. The second argument will be pattern.caseInsensitive, a constant on the pattern class. Running this. I'm still getting my H1 label because this flag is set. Using this method means the entire pattern is case insensitive, which may or may not be what you want. The previous method with the look-ahead meta character allows you to be more targeted. In this case, I could remove the capital letter A to Z range from my pattern, and I'll do that here. Let's review the output. I get the same results. Now let me just show you one other thing, which is why I really like the results method. I could just filter one of the tags in my stream. Let's say I'm only interested in the header tags. The types H1, H2 and H3 are captured in group 1. This captured text will have the actual text, which may or may not be uppercase. So I want to make the tag lowercase before I check that it starts with the letter H. Running this now, I now just get the data for my 3 header tags. Okay, so I hope this helped. At this point, I've covered the most important or more common usages of regular expressions you might need or come across. In the next video, I'll give you a challenge so you can test out your own skills. See you in the next video.